Bismillahirrahmanirrahim. This probably is an assignment question. This was sent by a student, and there was no reference of the book or the solution manual. I tried to find out, and there were 3-4 websites who were actually selling the answers. So I had to. I'm not sure whether the answer is correct or not, but I have followed the procedure that usually is followed for such type of a circuit for Thevenin and power. And I have several videos on this type of questions. So let's begin. This is the question. And there are 3 parts. We have to find the Thevenin's equivalent for the circuit at terminal AB. Then we have to find the value of RL, this resistance RL, for maximum power transfer. And finally, we have to find the value of the maximum power. So we'll do one by one. The first, we'll find the Thevenin's equivalent circuit at terminal A and B. So we remove the load, and this is terminal AB. Here we have to find the Thevenin's voltage and Thevenin's impedance. First of all, we have to convert the circuit into phasor domain so that we can easily solve it. And I hope you know how to convert into phasor domain, but I'll just repeat. Now the input signal is sinusoidal signal. It becomes easy to convert into phasor domain if we convert this into cosine signals. And in one or couple of videos, I have explained the technique that if it is cos to sine, that is S to S, then we use positive sign, and otherwise we use negative sign. So negative 90, since we are going from sine to cosine, therefore we'll have to use negative 90 with the angle. So this was the angle given. With this we use negative 90. And so it will be 10 cos 40 minus 100. And now we can convert it into phasor domain. We take the magnitude and take the angle. So in phasor domain, it will be 10 and angle minus 100. Similarly, we convert the inductor and capacitor. For that, we need the value of omega. And from here, you can see 4t is actually omega t. Therefore, omega is 4. Now 1 Henry will be J omega L is J4 into 1 or J4 ohm. And similarly, for capacitor, I prefer to use this formula, minus J divided by omega C. And again, omega is 4 and C is 0.1. So answer will be minus J 2.5. So our equivalent circuit, the circuit in phasor domain will be as shown here, replaced by the phasor values. And now we can find Thevenin, the voltage here. This will be Thevenin. Now since there is no current flowing in this, because the circuit is not complete, therefore whatever is the voltage here, same will be the voltage here, same will be the voltage across this. That means Thevenin will actually be 0.5 Ix. Okay, so this will be Thevenin. So let's write the KVL equation for this loop. So we're starting from here, negative sign, so minus 1000, then I into J4, and then 0.5 Ix. Solving for Ix, we just move it there. Take common Ix, and so Ix will be 10 angle minus 100 divided by J4 5, and the answer we'll get is 2.48, 177.12. Now you can solve this by the conventional method that you know that for division we have to keep the two terms in polar form. Now this is already in polar form. So you have to convert this into polar and then divide. But the easiest way is to use your calculator into complex mode. So first of all, we have to make sure it is in complex mode. For that, you go to mode and 2 for complex, so you select 2. So now it is in complex mode. And we'll just enter these two values. So for that, we'll use the fraction option here. 10, numerator 10, angle. So we write shift angle. This is angle. Shift angle minus 100. So minus 100. The numerator is done. Now we come to the denominator, and it is J4 plus 0.5. So we write 4i for J, 4i plus 0.5 and equal sign. So it is minus 248 plus 0.1 something. Now this is in rectangular form. We need it into polar form. So we write shift complex and this option for r theta 3. And this is the answer. Now this is in under root form. So to simplify, we press this button SD. It is now, you can say 2.48 angle 177. So this technique, if you learn, it will help you. All you have to do is when we're writing the answer, you just write in here in bracket that by using calculator in complex mode. So your teacher should not have objection that you have not cheated it. Anyway, so Ix found, now we can find Thevenin. Thevenin is equal to VAB is equal to 0.5 Ix, plugging in the value of Ix and solving. This is Thevenin. So we have found Thevenin. Now we need to find Thevenin. Now for Thevenin, I hope you know that when there is a dependent source, then we have to connect a test voltage source or test current source. And before that, we have to make the original source 0. So voltage source is made 0 by short circuiting. So we will be using test current source here. So we are using a 1 ampere test current source. We have already shorted the voltage source. So we need to solve this circuit. And Z from here we know is V over I. So in our case, it will be Thevenin will be V1 divided by I, whereas I is 1. So V1 divided by 1 or simply V1. So all we need to do is find V1 from this circuit. Now there are two loops. Left loop, this is the equation, J4I plus 0.5 I is equal to 0. And from here we take I common, and this either this should be 0 or Ix should be 0. Now this cannot be 0 because J4 cannot be equal to 0.5. Therefore Ix is 0. So this is one condition we find from the left loop. Now let's go to the right loop. Again, we are going like this. So minus V1 and then 1 ampere multiplied by J2.5 minus J2.5 and plus 0.5 Ix. Now we put the value of Ix is equal to 0. So we get this relation. From here, V1 is minus J2.5. And so using this relation, now we find Thevenin. V1 over 1 is minus J2.5 over 1 is equal to minus J2.5. So this is our Thevenin impedance. So now this circuit will be the Thevenin equivalent circuit. Okay, one more thing. Just to clarify, I'm writing impedance in this form, that is R plus X. So, that is why I have added a 0. showing that the rth term is 0 minus j 2.5. And so that was the answer. But some students might ask, why not use the test voltage source? So for them, I have just done this here. Using the test voltage source also, we can find the same answer. So from here now, our equation will be V over I. Now V is 1 volt, so IT we need to find Z Thevenin. And here also we take the left loop, I0, and then the right loop, putting value of I0, IT is 1 over minus J 2.5. So Z Thevenin is 1 over IT, and putting the value of IT, we get the same answer. Okay, so the Thevenin equivalent circuit now will be the voltage and the impedance we have found. This is answer of part 1. Now part 2 says if a resistive load RL is connected to the terminal, so this load, determine the value of RL that results in a maximum average power transfer to RL. So for maximum average power, the condition for RL will be this I have, it is explained in the book also, and in the example that I have solved, I have also highlighted this. So the main point is that for maximum power transfer, RL has to be equal to the magnitude of Z Thevenin. This you have to keep in mind. And after we have calculated RL, then we can find the current, and then we'll use this formula for power, half I square RL. Okay, so we were here, and we now RL using this formula, and as I mentioned, it should be Z Thevenin mod. So we have this value. Either you can calculate by the squaring of 0 and plus squaring of J25, or you can just get the Z Thevenin mod. And how do we get the Z Thevenin mod? This is Z Thevenin, and mod you can find R theta. And again, let me just, you can convert this from rectangular to polar, or we'll use the calculator simply. So clear this, and the value is 0 minus 2.5 I. And we have to, this is the answer we are getting. We have to go into polar form or the complex form. So shift complex R theta 3 equal sign. So the value is 5 over 290. We press SD. So it is 2.5 angle 90. So the magnitude is only 2.5. So the magnitude is 2.5 ohm. So this is the condition for part 2. So this will be our circuit now. Then part 3 is saying what is the maximum average power transfer to the resistive load? Determine N2. So we have found this value of RL. Now we have to find the maximum average power. And as we mentioned that for maximum average power, we will use this formula, I square RL. So for that, we need to find I from this circuit. And I will be V Thevenin divided by these two, Z Thevenin RL. Plugging in the values, 1.24, and then this is Z, this is R. And again, by using your calculator in complex mode, you can find this answer for current I. And then power will be half I square RL. So the answer will be 0.153 watt. I hope you have been able to follow this. If you find any mistake, please let me know. Thank you.